think it's my third LASCON. How many are here for the first time? Ah, it's a good showing. All right. So I've been in AppSec for about eight years. Joined after developing software for quite a bit. Certainly appreciate you guys joining me for the talk. I understand that I'm actually going against an invited speaker, so I'm glad that not speaking to an empty auditorium. So the title of today's talk is 10 reasons why your application security testing might not be working. And it kind of sounds like a lecture, right? I'll just give you 10 reasons. You're going to go fix them and everything's going to be peachy. No, right? So let's make it a conversation. So 10 reasons based on my experience of our company actually helping customers implement application security testing, but it's not a prescription. Right? So I'd love to hear some feedback from you. What works for you? What doesn't work for you? Maybe some of the reasons I'm going to talk about something that you've already experienced. Hopefully something will be new, and it will help you in your day-to-day job. Okay. All right. The slides are not going to be pretty, right? I made them with the help of some people, but there's very little marketing on them, and you'll see that there's no pretty graphics or transitions. So I'm sorry if you that's not what you expected. But quick show of hands: how many of you are in actually application security, and that's your day-to-day job? What do you guys, the rest do? QA? Development, maybe? Development? Okay. Now, the reasons are also not in any particular order. This isn't like Dave Letterman's, top 10. So this isn't necessarily the most important or the least important of them. But the key is that your application security policy might not fit your current situation or your immediate needs. Here's a good example. If you're just starting out with AppSec, there's a temptation. You just got a shiny new tool from a vendor, and they told you all about things that tool can do. The temptation is to turn all the knobs to the max and go scan and get everything that that shiny tool can produce. AppSec people actually like it usually, right? We get this long list. Look at what's wrong with our app. You need to fix it all immediately. Or the thing is that you don't really. And it's very easy to overwhelm developers with a lot of reports, with a lot of vulnerabilities. And the true, real defects, true, real security holes might be lost in that noise. So what we typically recommend in these cases, if you're starting out with AppSec, scan for just a few selected types of vulnerabilities, maybe as few as 5. SQL injection, cross-site scripting, things that are hard-coded password, things that are very easy for developers to understand. Typically, it's easy for you to explain what the a danger is in those, and you might get few results, a dozen results. Fix them, then correct things up a little bit. Tighten the screws up a little bit later. Another thing to do is to look at any compliance that you have to follow. Right? So if your application is subject to PCI compliance, there are very specific things you have to do, and don't do anything beyond it at first. Just focus on the compliance requirements. So, what do you think? Does that sound like a reasonable advice? Yeah. So I'm gonna try to do similar things with all the remaining 9, but speak up, and I'll try to ask questions. But speak up if you disagree. Again, I have thick skin. All right. Failing to communicate the remediation process. It's also something that we see quite frequently. Teams are so focused on finding vulnerabilities, finding that a vulnerability that justifies the AppSec, right? Oh, we have a hard-coded password. We have a SQL injection. This is why we need all this. But they sometimes forget about remediation. And it's actually not enough to just send back a PDF report or Excel spreadsheet with everything that you found. It's not enough to open JIRA issues. You really need to communicate a clear policy for what has to be addressed and how it has to be addressed, for example. What do I mean by addressed? Can anybody venture a guess? Addressed is not necessarily fixed. How are you going to handle exactly? How are you going to handle the risk? Maybe in some cases, the answer is I'm not going to fix it. I'm not going to fix it now. I'm going to put some external control over it. So, but communicate a policy that issues have to be looked at. They can't just remain unseen by anybody. Right? If you understand the risk and you're okay accepting the risk, yeah, that's fine. But addressed means looked at, not necessarily fixed. What we typically recommend in this case is sit down with your development team, look at their SDLC, and figure out where it makes sense, at which point it makes sense to look at vulnerabilities and fix them. Some companies do it at the end of every sprint, if you're agile. Right? Some do a sprint dedicated to fixing maybe not critical issues, but still high priority issues. Those are valid points or valid solutions. But again, there isn't a single prescription that can give you. So sit down with the development team, figure out what works for them. And if you make it easy for them, they'll embrace it. All right, reason number 3. Automation is not configured correctly, not done correctly. So I'm sure you've heard that automation is key to all this scanning thing, right? Just like automation did wonders to QA, right? Once we've, I remember times where QA used to be a separate team in the floor, in the basement somewhere. We developers didn't talk to QA. We didn't talk to anybody, really. But QA automation made wonders. Our software so much better today. You can actually introduce features and not break things because we go through a system of developing and immediately testing, running through a fairly comprehensive test cycle. So automation works well, but with AppSec, it's easy to make it intrusive. So for example, if developers have to change the way they build software in order for you to scan for vulnerabilities, you're likely to get pushback from them. Or you're likely not going to be able to do that at scale. Especially in an enterprise environment where you have hundreds of applications, potentially. Right? How are you going to make sure that everybody make these changes, and when their tooling change, they keep in mind that, oh, there's this extra step that we have to do. So automation has to be unintrusive, and it can't change the way developers run their SDLC. Well, to the extent possible, of course, but the less changes to SDLC you force developers to make, the higher chance of success you get. Okay. So that all works out with different tools. The thing I always recommend is to, again, look at the current SDLC, figure out the process, and then pick the AppSec tool, any other tool that works with that process, as opposed to evaluating your AppSec purchase based on what vendors claim they can do and what they can find, and then find out that, oh, it doesn't work with our SDLC. Developers don't want to use it, so it becomes a shelfware. Very nice, shiny, and good, but shelfware. Number 4, developer training. How many of you actually have a developer training, or your companies have developer training program, AppSec, specifically for AppSec? Yeah, not a whole lot, yeah, but still. In most cases, developer training is a thing you do once a year because kind of you have to. You go watch a bunch of videos and some better maybe organizations with a lot of bigger budget. Trainer comes over and you go over OS top 10 training, and it works for about a week, and after that you forget everything about quick, what's number 4 in the OS top 10 list? What's number 9? So it really can't be once a year experience to be effective. It's fine for compliance reasons. It's okay. So companies everybody has to go through application security testing, just like we have to go through lots of other mandatory testing. But it's not very effective. Developers need to be able to get help when they need help. So if they're working on SQL injection, you have to be able to access a resource that specifically focuses on SQL injection. It's relevant to the language that they're developing in, frameworks that they're developing with. That's what makes developer training effective. Running it once a year for a week doesn't. That's on-demand access to training. That's one good solution. Another good solution is knowledge sharing. Lunch and learn is a great way to disseminate information and keep developers current. What's wrong with lunch and learn? Nothing, right? You get free pizza, well, occasionally free pizza, and all you have to do is listen to somebody talk, and perhaps that could be an interesting talk. Sometimes, right? Bug bounties, even vendor presentations, they all work very well to keep training up to date. And training, again, is important because if developers make fewer security vulnerabilities, there's less work for you to do to remediate them. Well, not to mention the more secure software. Reason number 5, dynamic testing. Used to work well for waterfall development practices. We had design, development, QA phase, and after that you run your dynamic testing, pen testing maybe. And dynamic testing potentially can take hours or days. Right? The problem with it is that it doesn't really scale with the modern CI/CD type environment. If you're making multiple changes per day to your code base and you build multiple times per day, you can't take hours to test the change. So what do? Luckily, there are actually new technologies that can help. IAST is an up-and-coming security testing. You guys heard of it? Yeah. So the benefit is that it runs with your existing QA cycle. Hopefully, everybody already has a QA cycle, right, that they test their software. But it's not a separate step. It works in a CI/CD environment pretty quickly. Since you're already doing QA, might as well get information about your security vulnerabilities as well as that. Right? give it a try. I mean, IS is not, again, it's not a silver bullet. It certainly depends on technology, whether it's compatible with your application. It has some disadvantages of having to integrate an agent inside your app, potential side effects of that. But for technologies like Java and .NET, Node, IS seem to work very well by now. So several tools available in the market for that. Reason number 6, static tests. Of course, Checkmarx is a vendor, so we built our names in static analysis, so it's something that I understand very well. It's also one of the older technologies in application security testing as well. So static typically involves, again, if you run a full scan, involves 2-hour, 4-hour process. If you're using one of the software as a service providers, you in some cases don't even know how long it's going to take. There's some guidelines. We typically give you a response in X number of hours, but it might be 2X number of hours. And if you run it on premise, again, some peak times, scan times can be much longer than expected. And so, same problem is with DAST. If you try to do it multiple times per day, that doesn't work, right? What we typically recommend in this case is actually two-pronged approach. One, the beauty of static analysis is that it can be run incrementally in many cases. So just the changes need to be scanned. So make sure when you select your AppSec tool, or if you're a developer, if you have input into that, insist that quick incremental scan is possible. And also let developers use their IDE to scan code before it gets into CI/CD pipeline. If they scan and remediate most vulnerabilities already, there's less need for you to run a full scan in CI/CD. Less chances that CI/CD build gets broken. Broken builds are bad. Right? You don't want to be on the board as a person who broke the build. So ability to scan pre-check-in is also important. Sort of let developers clean up their code before it gets into quality pipeline. Kind of repeats the process we've done with QA. Right? Used to be that, again, QA was done by somebody else. Developers are responsible mostly for their testing in QA. Same with development. Same with application security. All right. So DevOps, right? How many people are actually using DevOps? Like DevOps. The challenge with DevOps, of course, is that you took two groups of people that didn't used to talk to each other, and now they have to talk to each other, have to work in the same process. So now we're trying to do DevSecOps, right? We're bringing another group of people. Used to be a separate team, maybe reporting into a completely separate organization. Need to talk to these groups. So it's easy to focus on developers. And we talked about training that you need to give to developers, context aware, and timely, et cetera, et cetera. But there's more to DevOps than just development. So do build engineers know why you're doing security scans? It's not just to give them extra work to do, right? Nobody really needs extra work. You need to train them not necessarily in the way to remediate SQL injection. They might not need to know that, but they actually need to know why SQL injections are important. Well, I guess SQL injections are probably easier to explain. But there's, even OS top 10 has some more esoteric security vulnerabilities that not everybody knows about. Do your build engineers know where your open source components are coming from? And they know that they have to run Maven build or something. Where does this repository reside? What happens if you deploy containers? Container security. Big deal, right? It's easy to download a Docker image from a repository and run it. What's in that Docker image? So you need to make sure that everybody involved in the development process actually gets application security testing. Things that, again, we recommend is a little bit of offensive security training, right? Kind of show what happens when some of these vulnerabilities get exploited, how they get exploited. There's several companies that do kind of fun offensive security training where you don't have to be a developer. You can be just basically an engineer to try your hand at hacking a real application. So those work very well with non-developers, build engineers, or the operations guys. It's fine. This should probably be higher. Again, this is not an ordered list. But if you neglect open source security, you don't have a very effective application security program. There are all sorts of stats, right? That 70% of our application is basically open source component these days. Who's not using open source in their applications? Okay. Here's your answer. All right, will do. But you actually have a good understanding of what's being pulled into your application through these open source components. One of the talks I give is on NPM in general, Node, package manager in general. And the interesting part about it is that it pulls in all the dependencies of all the packages that you include, right? And so you can start with maybe 4 components in your app, end up with 120, 150 components that are basically 5, 6 layers deep in that dependency tree. I can tell you that 90%, 90 maybe 5% of the cases, developer knows that they pulled in this component for what purpose. Maybe they know second level. There's very few people who know all 5 or 6. It's a huge tree, right? But they're just as important as your own code or as the first level of packages that you pull in. It can be the same vulnerability backdoor put in your application through 5th or 6th layer of dependencies. So what this means is that not only you need to test for these vulnerabilities, for open source vulnerabilities, but you also need a policy that clearly spells out how packages need to be selected. And packages can have security vulnerabilities, can have licensing restrictions. That's also bad, right? So developers need to understand the process for selecting open source components. And once you clearly explain the process, then it becomes much easier to set up a testing policy, testing process, and open vulnerabilities, open tickets if something is not compliant. Actually, in many cases, open source scanning is the first thing that organizations do, right? They don't do static analysis. They don't do dynamic analysis. They might do just a little bit of pen testing, but open source security is the first thing to do. They do. Why? It's very easy to explain. Hey, you're pulling in struts. this is the CVE. Here's a GitHub link to an exploit. Go run it. You'll see why this is bad. Now, when you get results from your static analysis tool or your dynamic analysis tool, there's some theoretical thing that might happen to your application. The CVEs in the database, they're not theoretical. There's one, two, a dozen exploits within a week, open source for everybody to use, right? For each of these vulnerabilities. So it's very easy to explain the value. And so actually, if you are just starting out and if you don't have a comprehensive or mature AppSec program, look at the open source security. It's the easiest thing to do, to start. Okay. So reason number 9 is that, again, it's very tempting to have one policy for all applications, right? One application security policy for everything. But it's not very practical. Not all applications are equally important in terms of your business. Right? They're not as critical. Right? You might have some accounting application that's externally facing that your channel partners use to submit orders. And you might have an application that takes food orders for the cafeteria, right? They're not equally critical to the business. And so if you try to create a comprehensive security policy that works for everything, if you try to do threat modeling for all of these applications at the same deliberate process, there's not going to be enough time in a day, a week, months. And creating these policies is only first step. Keeping them up to date is just as important, just as time-consuming. You start working in a threat model for an application, and if it takes you a few weeks, you'll find out that they don't use this framework anymore. They switched to this brand new shiny JavaScript framework that just came out. So your threat model is no longer applicable. And JavaScript frameworks come out probably every couple of weeks, right? And they're all designed to solve all the problems in the world until the next one comes out. So concentrate on the highest risk applications. Do threat modeling, comprehensive threat modeling for those. Outsource tier 2 and tier 3 to your security champions, maybe. You guys have security champion program in the organizations? Yeah, security champions are usually trusted, supposed to be trusted partners for the AppSec, right? Usually developers who are interested in security, want to do security, maybe want to kind of change career at some point. But if they're trusted partners, they can be trusted to do threat modeling for something that's not critical. Lessens the load on you, helps developers. All right. I don't know if that's the right image for the message or not. But what I'm trying to say here is that security vulnerability should be treated as bugs. A bug is a bug is a bug is the goal for all of us. That has several implications. One is that security vulnerabilities should be part of the same process as it already exists for handling field issues, QA-reported issues, failed test cases. It's a bug, right? And if your current development process involves opening a Jira ticket, evaluating it, assigning it to team lead for review, should do the same with security vulnerabilities. Developers shouldn't go through a completely different process to to work on security issues. Once you've actually established the security issues, same important as quality issues, actually becomes easier to build security into the app from the beginning. How so? If you're an agile developer, if you follow agile methodology, you have user stories, right? Typically, user stories have some function that an actor has to perform, right? Then you develop test cases to make sure that this action is done. You have this definition of done, right? That's agile methodology. And if something happens and the test fails, you have a bug, your user story is not done. Bake security into it. Once you're handling issues in the same way, don't just say, I have to be able to log in, right? I have to be able to log in and not have my password stolen. Right? Your definition of done, and if your password is hard-coded somewhere, it can be stolen and you're not done. So things like that. And it also makes it easier for developers to work with your issues. Again, they don't have to learn a completely separate process for reporting, handling, remediating the security stuff. The easier you make it for developers, and those of you developers, thank me later, the more effective your application security program is going to be. That's the bottom line here. So we've gone through 10 cases in about 35 minutes out of 45-minute presentation. Feedback from you guys, questions, feel free to share your experiences from implementing an AppSec program. I'm sure your fellow attendees would love to hear that as well. Again, this is what we've experienced over the last few years. May not be applicable to everybody. Andre.
I like that you talked about getting started with open source analysis early. And one of the reasons I preach the same thing is because of the attack rates. There's a lot of black hats, gray hats worldwide looking to attack struts. There may not be as many looking to attack your specific application. Do you think that's a valid argument, or do you have a different perspective?
I think for most of us, that's probably the case. I mean, if you work for a high-profile target, that may not be the case. There may be some specific reasons why people might be attacking your application, but I think for most people, most of us, that's true. It's easier for a hacker to deploy the struts exploit to botnet and hit whatever they hit than to try to break into your proprietary code for the same payback potential. So, yeah, you might more likely to get hit by attack against framework than your own code. Another thing to keep in mind is that your proprietary code, well, let's say you have a legacy application, right? You haven't been really changing it, maintaining it. That doesn't change. It doesn't have any bugs in it, right? Or it doesn't have any security vulnerabilities that can be exploited. But if it relies on third-party components, even if you don't change your application, somebody could find a hole in one of those components, and all of a sudden, your legacy application becomes vulnerable now. So that's why it's actually more important, in some cases, in some ways, more important to keep an eye on open source components, and vulnerability in open source components. It's easy to forget about your legacy apps. I haven't touched it in a year, so why do I need to retest it? Well, you don't need to retest your own code, but you do need to retest or recheck all other open source components that are part of it.
Any
All right.
other questions?
Got you 20 minutes back. So enjoy double boiled iced tea. Thank you for listening, guys. Hopefully it was helpful.